Hello, ladies and gentlemen. Welcome to Science 10. We're going to take a look at the kinetis. That's wrong. Here, let's just do this. The kinetic energy worksheet. It's always good to make sure you proofread things before you go live. So we're just going to go through the questions. I've given you out the answers before that. And actually, let's go back, and I just want to create a new page. Just to review, we're talking about kinetic energy. Actually, let's go back further. We talked about the force of gravity. We could calculate the force of gravity in newtons by taking the mass in kilograms times g, the gravitational field strength, g being a constant that's equal to 9.8 newtons per kilogram, or we could say meters per second squared. That's supposed to be a capital N. There we go. Either of these units work. It depends on how you take a look at where this value comes from for this constant. So it's perfectly fine. Then we took a look at work. Work is a force that is applied through a distance. And we saw that as long as the force and the distance were in the same direction, then we were doing work on something. And we saw the units for that would be Newton meters, but we had an alternate unit that we called joules. And then we said, all right, so if we take an object and we apply a force upwards and we raise it through a height, let's call that h, then we could talk about it having some potential energy, because if we release it, it starts moving, it starts dropping down. And we said that we could calculate the gravitational potential energy by going mgh, and we would talk about that unit as joules. But then we said, actually I was talking to a student yesterday, and we were talking about having, a 10-pin bowling ball above your head. It makes you afraid because it might drop and, hurt your head. But if we took it and rested it on your head, well, it really doesn't, it's not going to damage you at all, because your head is strong enough to support the weight, the mass of a bowling ball. It's when a bowling ball is dropping that it has some velocity. And so that velocity of the dropping bowling ball is what can be, hazardous to us. And so we talked about that when an object has motion, it has kinetic energy. And kinetic energy is found by taking 1/2 times the mass and times the velocity squared. And again, this is in joules. So this is potential energy, and this is kinetic energy. Now, in terms of the terminology or the symbology, I'm using E sub P because it's energy of type potential, and E sub K because it's energy type kinetic. You're going to see some places talk about potential energy and kinetic energy. This is perhaps a bit older. I used to use it for years, so it's still good. So then when we talk about kinetic energy, EK equaling 1/2 mv squared, the various forms of that could be to calculate, that's supposed to be a K, our mass. And our mass then would be our EK divided by 1/2 and divided by our v squared. Or we might be asked to find the velocity, which would be our EK 1/2 and m. But then, where's the squared? Well, this the square root of that. And so these really are the three terms that we would use, because these represent the three variables, EK, M, and V, that we can ask questions about. So have these equations out in front of you as when you're working through these, and that will be all good. All right, so here we go. Question number 1. What is the kinetic energy for a 150 kilogram object that's moving with a speed of 15 meters per second? All right, so the first thing we do is we go through and identify the values. So we have 150 kilograms. What do we measure in kilograms? Mass. With speed 15 meters per second. So we have this 15 meters per second. What do we measure in meters per second? Well, that's our velocity. What are we being asked to find? What is the kinetic energy? So we want to know EK. That's our question. So the equation we're going to use, EK is equal to 1/2 mv squared. And so that's going to be 1/2, well, our m is 150. Our V squared is going to be 15 squared. And so then if you pull out your Casio FX260 Solar, we're going to have to do the square first because of bed mass. Brackets, exponent, division, multiplication, addition, and subtraction. So 15 squared is 225. Yeah, I did that off the top of my head. So we're going to have 1/2, I'm showing off now. 1/2 times 150 times 225. And then we go times, and we get a grand total of 16875 joules, and that is our kinetic energy. Straightforward use of this. All right, let's continue on. An object is moving with a speed of 35 and has a kinetic energy of 1500. What is the mass of the object? All right, identify our values. We got a 35 meters per second. Units are important. They tell us that this is a velocity. Then we have this 1500. 1500 what? Joules. Well, if it's measured in joules, that has to be an energy. In this case, it's a kinetic energy, and they tell us that it's kinetic energy. It's just a matter of reading the question and making sure that you're following on. Is it easy to make mistakes when you're reading a question? Yes. You can read it quickly and miss part of what the information that's there. I've done that. I've done that myself. And then they say, what is the mass? Here's the question. Mass is what we are looking for. All right. So if we have EK is equal to 1/2 mv squared, then m is going to be equal to our EK divided by 1/2 and our v squared. So we're going to take our 1500 joules divided by 1/2 and divided by our 35. Don't forget to square it. So 1500 divided by, did I miss one? Sorry, just I was looking at an answer sheet and it wasn't making any sense. I think this might be question number 3 and I may have missed one. Okay, so we're going to go 1500 divided by 35 squared divided by 0.5, and we get a value of 2.45 kilograms. I had a question yesterday about, well, how many digits should you put down? Because this really, my calculator says 2.448979592. Well, 2 to 3 is always just a good number to use, 2 to 3 digits. You take Physics 11, Chem 11. You'll learn about, here we go, there's the 11, not the Y. You're going to learn about a topic called sig figs, significant figures, significant digits. And that talks about an analysis that we do to say how many digits we should report in our answer. This does not make any sense. It's okay for a calculator to punch that out, but in terms of analyzing the question, this is closer to, actually we should only have 2 digits probably, but we just say 2 or 3 and you're safe enough. Don't give me all of them. All right, here we have what is the kinetic energy of a 1200 kilogram object that's moving with a speed of 24 meters per second. All right, so we take a look. Here we have 1200 kilograms. Well, that's a mass. Here we have 24 meters per second. Well, that's a velocity. And they're saying, what's the kinetic energy? All right, so our EK is equal to 1/2 mv squared. So that's going to be 1/2 times our 1200 times our 24 squared. There was a time when I knew what 24 squared was. 576 times 1200 divided by 2, and we get a value of 345,600 joules. Big number, big number. An object has a kinetic energy of 14 and a mass of 17. How fast was the object moving? All right, so take a look. We have 14 joules. That's our kinetic energy. We have 17 kilograms. 17 kilograms, that's a mass. Velocity is what we're looking for. So our equation is EK is equal to 1/2 mv squared. So V would be equal to the square root, here it is, our EK divided by 1/2 m. All right, so let's plug in our values. We have 14 joules. 1/2 times our 17 kilograms. So you're going to go 14 divided by 17 divided by 0.5 equals, and square root that. And velocity then comes out to be 1.28 meters per second. There we go. An object is moving with a speed of 67 meters per second and has a kinetic energy of 500 joules. What's the mass? All right, so here's our information, 67 meters per second. That's really quite quick. And then we have 500 joules, and that's our EK. And we want to know our mass. So EK equal to 1/2 mv squared. So m will be equal to our EK divided by 1/2 v squared. So we're going to have our 500 joules divided by 1/2 of 67 squared. Plug this into the calculator. And we get a mass that's equal to 0.22 kilograms. Not a very big mass, but it's moving quickly. All right, what is the kinetic energy of a 478 kilogram object moving with a speed of 15 meters per second? Let's take a look. We have 478. 478 what? Kilograms. All right, that's a mass. We measure it in kilograms. Then we have this 15. 15 what? Meters per second. Oh, we measure velocity in meters per second. What is the kinetic energy? We're being asked to find the kinetic energy. So our kinetic energy is 1/2 mv squared. That's equal to 1/2 times the mass, which is 478 kilograms, times our 15 and squared. Don't forget the square. Don't forget to square this. That's an easy slip to miss that. So when working with kinetic energy, we have a square to that. So yeah, be aware. Be aware. All right, so times 478. And we get a value of 53775 joules, and that's our kinetic energy. All right, continue on. An object has a kinetic energy of 88 joules, mass of 45. How fast is the object moving? All right, summary, 88. 88 what? Joules. So that's our kinetic energy. 45 kilograms. 45 kilograms. Well, that's a mass because it's in kilograms. Question, how fast is the object moving? Velocity. That's what we're looking for. Okay, so EK is equal to 1/2 mv squared. So V squared, we're going to have a square root of EK over 1/2 m. And so for V with square root, EK is 88 joules. We have our 1/2 and our m is 45. So 88 divided by 45 divided by 0.5 equals, and then square root. And we get the velocity that's equal to 1.98, go away. 1.9, oh, go away, meters per second. And so there we go. And then an object is moving at a speed of 21 meters per second and has 140 joules of energy. What is the mass of the object? Right, pull out our values. 21 meters per second, that's a velocity. 140 joules, 140 joules. That's the kinetic energy. All right, what are we asking? What is the mass? Oh, m. And so our formula is Ek is equal to 1/2 mv squared. So m is equal to Ek divided by our 1/2 v squared. See, these things, they just come to the other side because they're connected by multiplication here, and so we use division to bring them to the other side. It's one way of looking at it. So our mass will be Ek, which is 140 joules, and then we have our 1/2 and our velocity being 21. Don't forget to square it. We pull out our calculator, plug in our values, and our mass comes out to be 0.63 kilograms. All right, finally, what is the kinetic energy of a 100 kilogram object that's moving with the speed of 12.5 meters per second? Right here, so here we have a 100 kilograms. That's a mass. And we have 12.5. 12.5, that's meters per second, so that's a velocity. What is the kinetic energy? Ek, that's what we're looking for. So Ek is equal to, or 1/2 mv squared. So that's 1/2 times the m, which is 100, times our 12.5 squared. 12.5 squared times 100 divided by 2, and we get a value of 7812, we'll say 0.5 joules, and that's our kinetic energy. So we missed one of the questions on there. I guess we could even do that. An object has a kinetic energy of 25 joules. I'm just reading this off the page. 25 joules, that's our kinetic energy, what we measure in joules. And it has a mass of 34 kilograms. 34 kilograms, that's a mass. That's what we got. How fast is the object going? So velocity is what we're looking for. So our Ek, this is the number 2, by the way. Our Ek is equal to our 1/2 mv squared. We're looking for v, so that's going to be the square root of our Ek over 1/2 m. So that will be square root of 25 divided by 1/2 times 34. And we get a value of 1.21. This is the first time one of my questions has looked different. Yeah, 1.21 meters per second. I was just going by the key. Now, they had 1.28, and that's probably from some rounding error that can happen in there. But this is the calculation that I come up with, doing it all in one step. All right, ladies and gentlemen, have a good weekend. And, get outside and enjoy the sun. There you go. All right, that's it. Bye-bye. Oh, yeah, you can watch me shut this down. Stop.